This is Advanced Math, Unit 4, Lesson 7. Today we are graphing cosecant and secant graphs. Graph cosecant and secant. Again, these are the reciprocal functions for sine and cosine. All right, I'm going to get right into it. Graph number 1, y equals secant of x. If you can graph sine and cosine fairly well, then you're in a good place because that's what these graphs build off of. Okay, so we're thinking here, what is secant the reciprocal of? And I'm hoping everybody's saying cosine. Y equals cosine x is the reciprocal of secant. So this is what we're going to think of graphing in our head. We're going to kind of plot the points out and see what ends up happening. Okay, so amp is 1 and period is back to 2 pi over b. 2 pi over 1 is 2 pi. Okay, I'm going to put 2 pi out here, and half of 2 pi is pi, and half of pi is pi over 2. 1 plus 2 is 3, cut in half is 3 pi over 2. 1 over 2, 2 over 2, 3 over 2, 4 over 2. Okay, and amp is 1. I'm just going to go throw 2 on there really quick. Okay, so we know cosine is the cup shape. It is the one that does this. Starts at the maximum, goes to 0, minimum, 0, maximum. Now I'm going to leave those 5 key points there, and I'm going to lightly, and very lightly because I will be erasing, sketch the cosine graph. So if you're working in pen, you're going to want to hit pause and switch out to a pencil. Okay, so I'm hoping, yes, you can see that. There is our cosine graph. Now, reciprocal functions takes a fraction and flips it. So 1/2 becomes 2 over 1, and stuff like that. So let's address these zeros first. What's the reciprocal of 0? Remember, 0 can be written as 0 over 1, 0 over 5, 0 over 7. It doesn't matter. 0 over a number is 0. It doesn't have to be 1. Typically we say 1. But when you flip that, when you reciprocal that, it does come out to be undefined. So the reciprocal of 0 is undefined, which means these key points right here, those zeros become asymptotes. So that's where we're going to start off. The zeros become asymptotes, and that will always happen with the cosecant or secant graph. When you're graphing the original function, whether the original function is sine or cosine, the zeros will always become asymptotes because the reciprocal of 0 is undefined. Okay, we have 3 sections: far left, the middle, far right. Left, middle, right. 3 sections here. Now, think about the reciprocal, like all these fractions here in here. I have 1/2, 1/3, 1/4, 1/5, 1/6. The reciprocal of all those is going to become 2, 3, 4, 5, 6, and so forth. They're going to get bigger and bigger. The smaller the fraction gets down here, the bigger the number's getting. So the real graph is going to shoot up like this, approaching the asymptote and getting close but never touching or crossing. Okay, so I'm going to erase this piece of the graph there because I've already used it to help me graph. And the same thing here, the reciprocal of all these fractions, 1/2, 1/3, 1/4, 1/5, are all going to or they're negative 1/2, negative 1/3, negative 1/4, negative 1/5, is going to become -2, -3, -4, -5, and it's going to shoot further and further down like this. So it looks like an upside down parabola. We don't call it a parabola because it's restricted between those asymptotes, where real parabolas are not restricted. They get wider forever and ever. Okay, so actually I'm going to put this light piece back. I'll erase it at the end. Okay, and then this little bump here, same thing. This little piece here, the graph, is between 0 and 1. What numbers are between 0 and 1? 1/3, 1/4, 1/2, 1/8, all those numbers here are going to flip and become really, really big and get close up towards the asymptote. Okay, so can you see where this piece is flipping upward and going up towards the asymptote? Same thing with this little, what used to be what we called half a hill, shoots upward, and this little valley shoots downward. And that there is your secant graph. Now I'm going to erase the inner piece. And that there is your secant graph. So let's see what cosecant looks like. Number 2, y equals cosecant x. Again, we start to think, what is the reciprocal of cosecant? And hopefully you're remembering it is sine. So sine is what we're going to graph. Amp is 1. Period is 2 pi over b. And b is 1, the coefficient of x, so it's just 2 pi. Pi. Half of 2 pi is pi. Half of pi is pi over 2, 1 over 2, 2 over 2, 3 pi over 2, and 4 pi over 2. All right, amp is 1. And sine graph is the snake shape. It's the one that starts at 0, goes to its maximum, 0, minimum, 0. And again, I'm going to lightly sketch my hill and valley. Now remember what I said earlier about zeros becoming asymptotes, and how many zeros do I have on this graph? I have 3 here, here, and here at 0, pi, and 2 pi. So on this particular graph, I have 3 asymptotes. I have 3 asymptotes. Where here I had the 2, which broke up into the left half, the middle half, and the right half. This one breaks up into 2 solid pieces, left and right. And notice that's a complete graph and a complete graph, like a complete hill, a complete valley, where here there was half a hill, a valley, half a hill, which is why we had only parts of what we called the parabola-like shapes here, only half and only half. And this one was the full one because it was the only piece that had the full valley. Okay, so what does that mean here? Here I'm going to have a complete U shape opening upward, and here I'm going to have a complete U shape opening downward. Okay, so just like that one flipped around, this U shape's going to flip around and move upward, going towards the asymptotes, and this one's going to flip around and open downward, going towards the asymptotes. And that's it. So here's the original hill, shoots upward. Here's our original valley, shoots downward. I erase the inner piece. And that there is the graph for cosecant. Okay, so why does this one have two complete U shapes and this one have only bits and pieces? It has one complete one and two half ones. Is because the cosine is the one that has half the hill, the valley, half the hill. And the two half hills have the two half U shapes. Where the sine graph has a complete hill and a complete valley, so the complete hill and the complete valley have the two complete U shapes. And that's pretty much it. We're going to do two more examples, but that's pretty much it for what secant looks like and what cosecant looks like. All right, moving along. Number 3. Let's try one with some translations. Y equals -3 cosecant x plus, before I give you that last plus piece, I want to come back to this page here and just recognize that where the original cosine graph oscillated between 1 and -1 forever and ever, our secant graph never exists. There is no graph between 1 and -1. Do you see that? When I graph these, as I continue, that'll be the rest of the half here, dot, dot, dot for the asymptote. The bump going downwards, dot, dot, dot for the asymptote. As we continue that, everything between 1 and -1, there will be no graph. It'll just be empty space right in between here. Forever and ever. There will be nothing here. Same thing here. Between 1 and -1, there's not going to be any graph. That's the piece that we erase, so there will be no graph. There will be no zeros for these graphs. All right. Y equals -3 cosecant x plus 2. Alrighty, so we think, what is this? The reciprocal of y equals -3 sine x plus 2. Amp is 3. It's reflecting across the x-axis because of the negative sign. Period is 2 pi over b, b being the coefficient of x, and it's 1. Vertical shift, it's +2, so it's going up. And horizontal shift, there is none. Start to label your graph. Okay, I have my -3 marked, and I am going to have to adjust this. I'm going to erase and adjust only because when I drew my graph I didn't anticipate the vertical shift, so I'm just going to shift this axis down a little bit. And I'm shifting it down a little bit so that I have room to translate it up to 2 units. Okay. So as we've stated before, whenever you have a vertical shift, you do your vertical shift first before the amp. So the vertical shift is 2, so I'm going to draw my fake axis. There's the fake axis, it's not an asymptote. The amp is 3, which means from here I'm going to go up 3. 1, 2, 3. If this is 2, 3, 4, 5. Is there, and I go down 3, 1, 2, 3, that is -1. Okay, so my original sine graph is going to oscillate between 5 and -1, which means once I draw the reciprocal, there will be no graph between 5 and -1. All right, it's negative sine, so it still starts at 0. Oh, let me label this. Okay, so my original point is a fake 0, a minimum, fake 0, maximum, and a fake 0. Again, that's for the reciprocal of sine. It's flipped around, so it's going down and then up, the valley and then the hill. And the max and the min are 5 and -1, because from the vertical shift of 2, I went up 3, put me at 5. I went down 3, put me at -1. Okay, so I'm going to lightly sketch this. Eventually, when you do enough of these, you won't have to sketch anymore. You'll just put your 5 key points, and from there you'll know what the graph looks like. Okay, our zeros are the asymptotes, and there's 3 of them, 1, 2, and 3. So 1 is here, the other one is here, and the third one is at 2 pi. So 0 pi and 2 pi. Okay, and let's go ahead and get our graph going here. There is a U shape opening upward, so when I graph it, it's going to go down. It always goes in the opposite direction, or think of it always going in the opposite direction of your axis, or your fake axis in this case, because we translated it up. Okay, this U is opening downward, which means our reciprocal function is going to open upward. I'm going to flip this around really quick. Notice my arrows are always going away from the x-axis. My arrows are always going away from the x-axis. Now here I translated up, so it's always going to go away from my fake axis being 2. Now if I translated this up far enough, let's say I moved up to 5 or 6, I would eventually cross the x-axis with these down here. And I would have x-intercepts. So that only happens when the translation is high or large enough to move me up above or down below the x-axis. But right now I still have no zeros. Once I erase this inner piece, you can see I get close here. I get up to -1, but I never hit the x-axis. Here I get down to 5 and never hit the x-axis. So this space, as I stated earlier, 5 and -1, will always be empty and have no graph. Okay, number 4. Y equals negative secant parentheses 2x minus pi. Y equals negative cosine parentheses 2x minus pi. That is what we're thinking about because we're graphing the reciprocal function. Amp is 1, and it is reflected because it's negative. Period is 2 pi over b, b being the coefficient of x, so it equals 2 pi over 2, which is pi. Vertical shift, the plus or minus on the outside, and there's none. Horizontal shift, you set that equal to 0. 2x minus pi equals 0. Go ahead and solve that. Add your pi, divide your 2. You should end up with pi over 2, which means we're going to have to adjust our start and our end. Our start is pi over 2 because that's a horizontal shift. The end is pi over 2 plus the period length, which is pi. Pi is equivalent to 2 pi over 2, 2 pi over 2 plus 1 pi over 2. Your end is 3 pi over 2. Okay, 1 pi over 2, 2 pi over 2, 3 pi over 2. pi over 2, 3 pi over 2. Back here in this one, you may want to erase this so you don't confuse it later for an asymptote. Again, that was just our fake axis to help us graph. It is not an asymptote. All right, back to this one. 3 plus 1 is 4. 4 cut in half is 2. So this is 2 pi over 2. 2 plus 1 is 3. 3 cut in half is 1.5. Pi over 2. 2 plus 3 is 5. 5 cut in half is 2.5 pi over 2. And this is a cosine graph, and it's negative. So let me put my amp in there, 1. Negative 1. So this is my start, that is my end. And with cosine graph, it usually starts at a maximum, comes down and back up. But because it's negative, it's going to start at a minimum, 0, maximum, 0, minimum. So that there would, I'm going to lightly sketch it, be your cosine graph, oscillating between 1 and negative 1. Okay, let's get our zeros in. I only have 2 here for the secant graph, or for the cosine graph. I only have 2 zeros, which means I have 2 asymptotes for the secant graph. So remember, because the cosine graph has only 1 complete bump and these 2 half ones over here, that's the one where we do not have 2 complete U shapes like this one here. So what ends up happening is right here I have this half upward U, so I'm going to have a half downward parabola-like shape going towards the asymptotes. Here I have this complete hill, this U going downward, so I'm going to have a complete one going upward. Again, they're not parabolas because they're sandwiched between the asymptotes, but they look like parabolas. This one here, I have this half a valley, this half U going upward, so I'm going to have a half U going, or a half parabola shape going downward. That there is my graph. I erase this complete bump in the middle, and the one on the far right. And that there is your graph. That is it for now. We will do some together in class. Make sure you have your questions ready to get cleared up in class.